Today we're going to give a presentation about Swarm. We're going to start by the basics and give a quick overview for those who are not familiar with the project. And then we're going to move on and explain what we released recently and the direction in which we're headed. So Swarm is a Docker native clustering solution. The reason we created it was to run containers on multiple hosts. So for the past couple of years, Docker has been great for developers to run containers on their own machine, but it turns out when you want to actually run a production, you have more than a single machine. So we set out to find something that could be used as well for developers and DevOps. As I mentioned, Docker is great on a single machine. Now you have a production, you have a few machines. And the way people have done it in the past is to simply use the same CLI and just connect point to every Docker engine out there. And maybe they create a few shell scripts or they use some third-party application to manage their cluster. Well, Swarm, you can see it as mostly like a proxy. So it's between your Docker engines and your CLI. We picture here a CLI, but it could be any tool that actually speaks the Docker API. So if you have a CI system or some tools you wrote on top of the Docker API, they're going to work as well. In a nutshell, Swarm takes a multitude of Docker engines, and it exposes them as a single virtual Docker engine. It speaks the exact same Docker API, which is very important for us. That's in order to be portable. So if you write some code that talks to Docker, it can automatically talk to Swarm as well, which means that your single host code is going to work on a multi-host setup. Again, another goal was to be extremely easy to get started. We didn't want you to have to bootstrap an entire storage cluster or some configuration management systems before actually starting to use Docker Swarm. And last but not least, we follow the same principle as Docker. So the batteries are included but swappable, which means that we're currently shipping with a default scheduler that we are aiming can solve the issue of multi-host for about 80% of the people out there. And for the remaining 20%, well, we have a scheduling API, which Victor is going to talk more about later. And anyone can just write their own cluster and replace the default one we're shipping with. So just to get a sense of the timeline we have here, it all started back in October, so it's really quite recent. And around in February, we released our first version, so 0.1. And yesterday, actually, it turns out that we released a new version, which is 0.2. And we're planning to release 0.3 in June. So we are following the same release cycle as Docker itself. Speaking of Docker 0.2, so again, the most important thing for Swarm is to be 100% compatible with the Docker API. So in the last release, we got to about 85%, and we're aiming to be 100% compatible with Docker by 0.3 in June. Swarm supports resource management, so CPU, memory, and pretty much everything that is unique on machines is going to be taken care of by the scheduler. We have some advanced scheduling features, such as constraints and Affinity, which, again, Victor is going to demo later on. And in order to discover your machines, we provide different, again, plugins. So we have a default one that just relies on the Docker Hub, but we're also shipping with support for etcd, console, and Zookeeper. And finally, Swarm is using the same, since 0.2 is using the same authentication mechanism as Docker. So we use TLS between the CI and Swarm, and between Swarm and the engines. So I'm going to let Victor continue. Victor.
Yeah, so at first I will talk about the hosted discovery service. As Andrea said, it's really important in Swarm that it's really easy to use and easy to set up. So as you can see here, with only 3 commands, you can start a Swarm cluster. Basically, you do a Swarm create. It will give you a token. And then on every machine you have, you just do a Swarm join with this token. Then it will basically talk back to the Docker Hub and say, this is my IP, I belong to this cluster. And then you start the manager, again with the same token, and that's it. Of course, if you don't want to use the hub, or if you are in a private network and you don't have internet, you can also use your own etcd or Zookeeper or console. We have nice Go interfaces, so contributions are welcome if you want to add another discovery service. We are really open. Just go on GitHub and we will discuss about it. Next, I'm going to talk about the Swarm scheduler. So the built-in scheduler in Swarm, it's quite easy to understand. It's quite simple. Basically, it's a 2-step process. So thanks to the node discovery service, we get a list of nodes. And then the first step would be to apply a bunch of filters, like those ports, constraints, or affinity. For example, ports. Let's say you want to deploy a container that will bind on the port 80. If we know that on one machine the port 80 is already taken, the port filter will remove this node from the list of candidates. And once we have those candidates, there is the second step, which is using a strategy that will rank and sort all the nodes. Currently, we have 3 strategies. Bin packing, where basically we try to put as much containers as possible on one machine to leave the others empty. Spreading, which is basically the other way. We try to put containers on every machine, and random just for testing. And again, like discovery services, those are well-defined interfaces in Go. So if you think about another filter or another strategy, you are more welcome to contribute. Then resource management. So as Andrea said, the goal of Swarm is you continue to use the Docker CLI that you use on your laptop, but on your entire cluster. So for example, if you want to start a container that will use 1 GB of RAM, it's just a regular Docker run, nothing fancy. So Docker run -m, 1 gig. And when you do that, Swarm will look at all the hosts in the cluster and find a host with 1 GB of RAM available. Same for CPU is -c. And in Swarm, resources are not only memory and CPU, it's everything that's unique. So for example, ports are unique. As I was saying, if you try to start a container and you bind on the port 80, Swarm will schedule the container on a machine where the port 80 is available. More resources are coming. We would love to have network interfaces. So basically, we would love to have a container and say, I want a dedicated network interface. So we definitely want to do that. Now let's talk about constraints. And at the end, I will do a live demo, so maybe it will be more easier to understand, but I'm just going through the slide here. So constraints, we have multiple constraints. So first, today in Docker, when you do Docker info on a regular Docker, you see a bunch of information like the operating system, the storage driver, the kernel version, or things like that. So by default, you can use all those values to apply constraints. So here in the first example, if I want to start a container, and I want this container to run, I don't know why, but you will to do that. But if you want your container to run on a machine where the host system is Fedora, you can do that. As you can see with the stars, it supports like regapes and globing, so you can really specify the constraints you want. So same with storage driver. And we also have custom constraints. So since Docker 1.5, when you start the daemon, you can add labels to your Docker daemon. So when you start the daemon, you can say, I want this daemon to be labeled as like a region equal US East, or I want this daemon to be labeled as storage equal SSD. And once you have done that, you can use those labels as constraints. So here in the example, we started the daemon with region equal US East, and then with -e, I just add the constraints. I want to start this container on any machine that match the constraints region equal US East. And the last one is when you want to start a container on a specific node, you can do that with the node constraint. And kind of similar, we have affinities. So let's go through the example here. First, you have the containers affinity. So here I will start a web container, an Nginx container. I name it web. And then, for example, if I want to start my logger container, I want my logger container to be next to my web container. So I can do that with the containers affinity. It looks like constraints. It's affinity column, container equal web. And Swarm will look for all the hosts where the web container, find the host with the web container and put your logger container next to it. We also have anti-affinities, and it also works with constraints, so you can put an exclamation mark in front of the equal. So let's say you want to start a Redis cluster. You will start by starting your Redis master. So the first line, I'm just starting a Redis master simple, and then I want to start a slave. And here I don't want the slave to end up on the same machine as my master because it wouldn't make sense. If the machine goes down, I lose both the master and the slave. So I can use an anti-affinity with affinity column. And basically I say I don't want to be in a machine where they already have a container starting by Redis. So that's really powerful. And also we have image affinities. So basically this Docker run with image equal Redis will force Swarm to pick a host where the Redis image is already pulled. So it can be useful if you don't want to pull the image from the hub, or if it's an image you built locally on one machine. With this affinity, you can specify I want to run on this host. Since Docker 02 that we released yesterday, we also have soft affinities and soft constraints. So I will go really quickly on those, but basically, if you take the affinities, for example, the example with the Redis, let's say we have 3 machines. You start one master, you start one slave, it will go on another machine. And if you start another slave, it will go on the third machine. And if you if you want to start a third one, if you use an affinity, Swarm will refuse to start your slave because it will say, I don't have any host without a Redis container. So you can use soft affinities. Basically, you can put a tilde in front of the affinities. Basically, it will try to apply the affinity, and if it can't, it will just don't use the affinity or don't use the constraint. So that's really useful if you want to, like you have a cluster of 3 machines, you want to start 5 containers, you want to try to spread them as much as possible, but still you want to run 5, you can use soft affinities to do that. Now let's talk about the integration. So when we announced our orchestration suite, it was in DockerCon in Europe in December, we announced 3 projects. So Swarm that we are presenting, but we also announced Machine. So to be really quick, Machine is a tool that lets you start Docker machines on any cloud provider or on your local VirtualBox or VMware with a simple command. And it's fully integrated with Machine. So here is just an example, but basically if we do like machine create -d Azure, it will use the Azure driver and start a Docker machine. And you can specify the token I showed earlier. And this machine on Azure will be automatically joined the Swarm cluster. So if you replace Azure by GCE, or you get a machine on GCE, if you replace Azure with VirtualBox, you get a local VM. We also announced Compose. For those who are familiar, Compose is like Fig. So you describe your entire stack in a YAML file, and then you use this YAML, you describe your stack, and then you do like compose up, and your entire application, your entire stack will start in Docker. So really the things that is really nice with Swarm is, as Andrea was saying, we're using the same API, exact same API. So Compose, for example, you just have to do compose up against Swarm, but instead of against Docker daemon, and it will work. So it will start deploying your app on your Swarm cluster. We said partially integrated because for now we still have a few things to fix. For example, when you link 2 containers, they end up on the same machine. It's because of the way links works today in Docker, but we are like Docker is working on that, and the networking in Docker will evolve pretty soon. And talking about the scheduler integrations, so we are integrating Swarm with Docker and the DSOS with the help of Mesos. So basically, we aim to support 100, 200 machines with a built-in Swarm scheduler. But if you really want to use Swarm at scale with a huge cluster, you can use Swarm on the Mesos cluster. Basically, it will look like same command, so Swarm manage. We just add a -c saying I want to use a Mesos driver, and then you can give the zookeeper URL of your masters, and it will work right away. So just a quick schema. Let's say today you have a Mesos cluster. So at the top, it's my multiple slaves. In the middle, it's the masters. So here, only one is drawn, but I hope for you that you have a quorum and you have multiple masters. And on the bottom, you see all the apps that are currently running on Mesos, like you can use a Mesos CLI, Marathon, or any other framework, Chronos, or any framework. And basically, Swarm will act as a framework, so it will be at the same level as the CLI or Marathon. And thanks to Swarm, you will be able to use the Docker CLI on your Mesos cluster. And again, because it's Swarm, you will be able to use any tool that relies on the Docker CLI directly on your Swarm cluster. So you could write a compose.yml, do compose up, and it will start on your Mesos cluster. So this is not done yet, but the work has started with Mesosphere. It is led by Mesosphere. So it will go out pretty soon. Yeah. Now let's do a quick demo. So it's pretty much the same slide at the beginning, just two additions. As you can see here, some machines are tagged. So the machine on the left is tagged as a region equal US West, and the two on the right are tagged as region equal US East. And also each machine has 2 GB of RAM and 1 core. So what I'm doing here is I'm going to start Swarm. I'll use the debug mode. So I'm going to manage a cluster. And I will pick the... Wait. Yeah. So I'm going to start Swarm, so I will use the debug flag. Then I'm going to say I will manage a cluster, and I will pick the strategy bin pack. So here I have the token, the cluster, the discovery token in my environment. So when I do that, it's working. As you can see here in a few minutes, a few seconds, should. Yeah, so it picked up those 3 machines, so Ubuntu 2, Fedora 1, and Ubuntu 1. Those are those 3 machines. And once I've done that, I can just use the regular Docker CLI. So for example, if I do a Docker info, here, the info, instead of talking to a Docker daemon, it's going to talk to Swarm. So if I do a Docker info, as you can see, I have no container running. I have, using the bin pack strategies, a bunch of filters, and I have 3 nodes with their CPU, memory, and addresses. And then we use the regular Docker CLI. So I'm just going to demo a really simple example of resource management. So let's start an Nginx container, for example. And I'm going to say, I want this Nginx to take 1 GB of RAM. So I just use -m 1 GB. When I do that, I can see here, the cluster was empty. So basically, a host was picked up at random. Here it was Ubuntu 2. Yeah, it just... no, the screen is too small, so... Yeah, so my container ended up on Ubuntu 2. I can start another container, and as we have chosen the bin packing strategy, this container is also going to end up on Ubuntu 2, because as I said, with bin packing, we try to put as much containers as possible on one machine, so the others are empty. If I start a third one, it's going to choose any machine that is available, empty, so in this case, Fedora 1. And now if I want to start a 2 gigs container, here Fedora 1 has only 1 GB of memory left, so this one will go to a third machine, which is Ubuntu 1. Yeah. So if I try to start another 2 gig container, Swarm will refuse to start my containers because Swarm knows the state of your entire cluster, and he knows that there is no container, no host with 2 GB of RAM available. Of course, if I remove the container which is alone on Fedora 1 and start my 2 GB again, it's working. So yeah, Swarm really knows the state of your entire cluster. So that was a really quick example of resources. Let's show affinities, for example. So first, I'm going to clean up the cluster. Again, the command you are used to use. So yeah, let's do the example I was talking about. So with the Redis cluster. First, let's start Redis master. So -d -- let's expose the Redis port and name it Redis master and the Redis image. So here I see this container started on Ubuntu 2. One thing you can notice with Swarm is inside the PS output, you see the IP, the actual IP of the node. So you can connect to this IP in this port, and you will reach your Redis container. You can do Docker port on my master and port, and then you have the IP in port. We can do almost every command that Docker supports in Swarm. So like you can, for example, see the logs of your Redis master. You can like even exec. So if you want to start a bash to debug something in your master, you can do a docker exec bash, and yeah, you get a bash in your Redis master container. So let's continue with affinities. So I started the master on Ubuntu 2. So now I want to start the slave. So it's a docker run -d. I will name it like Redis 1, for example. And Redis. And here I'm going to use an affinity to say, I don't want this slave to be next to my master. So I use -e. For now, we use affinities, and constraints are via environment. It might evolve in the future to use labels, but for now it's environment. So you say affinity container, and I don't want to be, so not next to something that starts with Redis. And if I do that, this slave went to another host. So in that case, it went to Ubuntu 1. If I start the same command again, it's going again to pick a host without a Redis container. So it went on Fedora 1. And if I tried to start my third one, Swarm will refuse because he knows there is no host in my cluster that satisfies this constraint. So of course we have much more to demo, but we don't have time. So just keep like Swarm handles most of the commands Docker would do. Like you can do a Docker image, and you see all the images in your cluster. So yeah, we invite you to go to GitHub to check out the project. We're also really active on IRC, so you can go on Docker Swarm on Freenode. So yeah.
Great, a round of applause, please.